Hello, can everyone hear me? Okay. How many people here have neighbors? Raise your hand if you do. Okay, it's reassuring to know no one lives in the middle of a desert. How many of you have neighbors who have Teslas and solar panels and brag about them? Okay, I'm glad I see those many hands because I know for a fact we do. And let me let you in on a little secret. It's not nice. So, everywhere you go, you hear about them. The new silver bullet to all our environmental problems, the glamorous poster child of clean energy, the thing that's supposed to be saving polar bears and stopping Arctic ice from melting, the things with zero emissions that are saving our planet. But what if I told you that these things, these solar panels that we said were saving our environment and saving everything in it, were secretly poisoning it? How many of you would believe me on that? No one? I thought so. Well, let me show you why. The first time I stumbled upon this, I was knee-deep in research for a completely different project. I was researching how hydrogels, which are water-absorbing polymers, can help to extract heavy metals from soil, from our food supply, and from our water systems. And I was scrolling on a research paper, being the nerd I proudly am, and I came across a pie chart showing the major contributors to climate change and heavy metal pollution in our environment. And nestled right there, next to battery disposal, mining runoff, and factories, were solar panels. And I couldn't believe my eyes. I was like, are we talking about the same shiny little rectangles that are supposed to be saving our planet and saving the polar bears and supposed to be lowering our electricity bills? I kept rereading it, hoping that I had made some sort of mistake, hoping that there was some sort of misunderstanding. But the more that I read, the more I realized the things that were supposed to be the poster child of clean and green energy were secretly poisoning it. So, solar panels are built using a whole cocktail of materials, right? They're mostly silicon, but that's just a surface level story. To improve conductivity, to boost efficiency, and make sure that the solar panels last longer, manufacturers add things like cadmium, lead, arsenic, and mercury. They also add other heavy metals, and some of these metals, like cadmium telluride, are extremely toxic, even in small amounts. These panels that are manufactured in factories, often without strict waste regulation, and once they're done with their use for about 25 to 30 years, they become waste. And let's be honest, do you really think that companies who love corporate benefits and who love dollar bills would take the time to recycle them? Any guesses on where these wasted solar panels go? You? Close. Anyone else? Yeah, not landmines because those are something completely different, but landfills. Yeah, landfills. And since recycling is so limited, the toxic material that goes into these landfills just stays there, slowly breaking down and contaminating the water supply and the soil. So here's where the danger begins. So let's say you have a ton of solar panel waste. And no, I don't mean a ton as in a lot. I mean a ton as in 1,000 kilograms. So now let's just say that 1% of that is lead. Statistically, it's more. And there's also other types of heavy metals in solar panels, but just for the ease of our calculations, we will use 1%. So the truth is that lead is about 4.8%, but we'll stick with 1%. If you would like to at this stage, get out your calculators so you can follow along from what I am talking about. If you have your phones on you, then feel free to put your calculator down. So on your calculators, do 1,000 kilograms times 0.01. This gives you how much of the 1,000 kilograms is actually made of lead. You get 10 kilograms. Raise your hand if you've got that so far. Great. So you're all with me. So we have 10 kilograms, right? 10 kilograms of lead. Now if we type in 10 times 1,000 to convert to grams, we get 10,000. Am I right? So if even 0.5%, not even a full percent, I'm not talking about 50%, I'm talking about 0.5%, 0.05% leaks into groundwater, we're talking about 50 grams of lead contaminating local water systems. So now you can do 100 divided by 2 to get 50, and that is how many grams of lead would be contaminating water systems. Now, the World Health Organization says the safe concentration of lead in drinking water is no more than 0.01 milligrams per liter. So now if we convert 50 grams of lead leaked into water, that's 50,000 milligrams. So you can type the 50 that you have right now times 1,000 to convert to milligrams, and you will get 50,000. Now, with the safe limit of 0.01, you find that the amount of lead in the water that we calculated, the 50,000 milligrams, is enough water for 500,000 people, rendered unsafe, all from the breakdown of a single ton of solar panels. This means that in theory, the whole of the Middle East and North Africa's water would be poisoned with a single ton of solar panels. Now, this isn't a theoretical problem because if we look at the data, by 2050, the world is expected to have wasted 78 million tons of solar panels. This is 78 million times of the number we have just calculated. 78 million times by the numbers we just crunched is 78 with 11 zeros. That is more zeros than Elon Musk's bank account. That is 78 with 11 zeros. That is 7,800,000,000,000,000,000. But there's only 8 billion people on this planet. So are we technically poisoning tens of 100 times more people than are on this planet? And we're looking at a future where these very things are supposed to be protecting our environment, not killing everyone in it. So what do? Do we give up on solar panels? Absolutely not, because the point of this is not to ban solar panels. The point of my talk is to show you that there is room for improvement. My goal is not to tear down solar technology, it's to fix it. And here's where things really get exciting. In my original research about hydrogels, I learned that these smart polymers, which are basically water-absorbing polymers, if I simplify it down, polymers meaning materials, can trap heavy metals through a process called sorption. That's basically just the fancy word of absorption in science. So imagine a sponge, but way more clever. These metals, the heavy metals that are used in solar panels, can stick to the hydrogel instead of floating freely in the water, which reduces the concentration and toxicity. So now there's a formula we can use to model this behavior, and it is called the Langmuir isotherm. And it looks like this. Q equals Kc over 1 plus Kc. Kc meaning multiplying the two variables. I'm sure all of you knew that. So if we break this down, Q is the amount of metal absorbed per gram of hydrogel. So if we apply this formula, we can find out how much metal is actually absorbed by these hydrogels. Then K and C represent respectively the binding constant, which is how much of the metal actually sticks to the hydrogel, and C, the concentration of metal originally in the water. So if we plug in the numbers of an average hydrogel that you can make at home with just water and guar gum, you get 2 times 5 over 1 plus 2 times 5, which means with a basic hydrogel you can make at home, 0.91 milligrams of lead are removed from a body of water. This means that if we just had 10 grams of hydrogels, we could remove 9 milligrams of lead from water systems. It's small scale, but it is scalable. Because if you can imagine thousands of water filters made of these hydrogels powered by AI as well, or better, or hydrogels installed directly inside solar panel disposal centers, catching these metals before they even reach the environment. This would be so much better for our environment. This would make the green energy actually green. If we look back at the data we used earlier, the World Health Organization said that the safe drinking concentration of lead in water is 0.01 milligrams per liter. This means that 910 million people currently could potentially be drinking contaminated water in a year. Now, this is theoretical, but if we consider a less theoretical case of 250 lives we've saved with this 910 milligram basic hydrogel, we can times it by the hundreds of thousands, and we get 900 million. We could be saving 900 million people's water with just a single gram of hydrogel. So, why stop there? We can also look at programmable materials, which are materials that change their behavior based on the environment. We could build solar panels with smart layers that detect metal concentrations inside when they start to rise. Maybe it triggers a warning light, maybe it activates an internal filtration layer. Or maybe it connects to a central database of waste management, so the system knows exactly when and where the contamination could happen. And yes, more math could help. I know most people hate math, but more math can help. One example is Fourier's law of heat conduction, which tells us how heat spreads through a material. Once again, the Q from before. Q is equal to negative K times dt over dx. For everyone who knows, dt over dx is the differentiation of t and x, but another way to put this is basically the steady rise or the gradient of that. So in this formula, Q is the heat transfer per unit area, K is the thermal conductivity, and dt over dx, as we talked about, is thermal gradient. So why does this matter? Because heat accelerates material degradation, as we all know. In more heat, the faster your solar panels will break down. So by managing that temperature gradient and by spreading heat more evenly, we can make panels last longer, reducing the amount of toxic waste in the first place. Now let me ask you the same question I asked you at the beginning. How many of you believe me now that solar panels are indeed poisoning our environment? I see more hands than I did earlier, which is great. And now I want you to remember, solar panels are not evil. Solar panels will not kill everybody. They're revolutionary. But revolution without responsibility is just chaos in a prettier dress. And we cannot afford to blindly chase green energy without asking what happens if and when it does break. The dark side to the sunshine is real, and it is up to us, students, scientists, engineers, and maybe even TED Talk speakers and audiences like myself and you, to drag it into the light. Pun intended. Because the truth is, solar panels have a dirty secret. But now that you know that, you can be part of the clean solution. Thank you.
Thank you.